This is a great example of a word puzzle, and the ones you'll see a lot are bicycles, Ferris wheels, and water wheels. And the reason I bring up the other two is because a bicycle is on the ground. Bicycle is on the ground. So the minimum of the cycle will be, the ground is considered the x-axis. So whatever we design here, the minimum will be at the x-axis, and the max will be up here. It'll never cross the x-axis because a bicycle is on the ground, so it's never going to go beneath the ground. A Ferris wheel model will always be slightly off the ground because they'll always say, 1 meter off the ground so people can get on it. And it'll usually be represented above the x-axis. And a water wheel is represented inside the water, in which part of the wheel is underneath. I bring this up because it's important to understand where you would place the models. So part of the water wheel is going to be beneath the water to collect the water. This is important because a lot of students don't understand what x-axis represents. But here they're telling me I have a bicycle, and it says whose center is center, so the center of the bicycle here, is 20 meters above the ground. That's the center, which means it also has another 29 meters here. This tells me my axis will be at y is equal to 29. Because the axis just happens to be also the center of the wheel. Oh, wait. Here we go. We got something else. So that's going to be the axis. So the pedals of a bicycle are mounted on a bracket whose center is 29. So that means we're going to be 29 above the ground. That's still the axis. But each pedal is only 16.5. So that's going to be the amplitude, 16.5. Up and down. Right away, I can see if we're 29 all the way down and only 16 to the pedal's min is going to be 29 minus 16.5. So that's 23, 13, 12.5, which means the min point here is going to be 12.5. And the max point is going to be 29 plus 16.5. So min point is going to be, let's do the formula. Min point is axis minus amplitude. The axis we just said is this. The amplitude they've told us is that. So the min value is going to be 12.5. Max value is axis plus amplitude. So the max value is going to be 29 plus 16.5, 35, 45.5. Which means their total distance apart should be 22, 33, which it is. Twice the amplitude, the diameter of the wheel, diameter of this rotation. They tell us a bit more information too, but let's figure out the axis is always going to be the center of the wheel. That's the axis. Here's the last part we got to figure out, the period. It's the tougher part because they phrased it in an interesting way. By 12 cycles, they mean we go around once, twice, 3 times, 4 times, 5 times, 12 times in a minute, which is 60 seconds. We're interested in how long does it go around in once. Well, if it takes 12 times in 60 seconds, we divide both by 12. It goes around 1 time in, what is that? 12 goes 5 times. So it goes around 1 time in 5 seconds. Simplifying the fraction. So if it goes around once in 5 seconds, the period is 5 seconds. To make a period 5 seconds, I multiply my x by 2 pi to get rid of it and divide by 5. So this will be my multiplier or my transformation of x. Sometimes they even throw in another thing like he starts pedaling 3 seconds later. In other words, that the sine curve is translated 3 to the right and has to start there. So watch out for that as well. But they didn't. So now I have all the information I need to construct this. Y is equal to A. Now also be aware when we start pedaling, it says here's an important part. You have to read these too. It says the pedal starts at the topmost position at 0 seconds. So which graph starts at the top? Well, sine starts there. If I want my sine to start at the top, I have to push it a quarter period left. So I can use the sine curve. Or, more easily, the cos curve starts at the top. So why not use the cos curve? And I'll show you how to transform the sine curve. So here's the formula that we use. A, cos, B, I don't think they use B, but I mean IM, x minus c, plus d. Well, I told you the s is always the axis. And we've already figured out, they've told us the amplitude, 16.5 up and down. The cos is not, starts at the top, so I don't need to reflect it. If it started at the bottom, I'd have to reflect it. And we figure this out. And there's no transformation because they tell me I start at 0 seconds. So this is the formula. However, if I wanted to use the sine curve, and sometimes they'll say make a map from both cos and sine, the cos starts at the top, so I don't need to move it left. But a sine curve, when it reaches the top, it's a quarter way through the period. A quarter of 5 is 5 over 4. So if I was to use a sine curve, I'd have to shift it to the left by 5 over 4 to get it to start at the top. So the sine curve would be this. Everything's the same, but I need to move it to the left by a quarter of 5 seconds, or a quarter of period, and the period is 5 seconds. There we go. If I needed either to start at the bottom, I'd have to put a negative in either of them, just to show that this works. We put the axis at 29. According to me, the midpoint should be at 13, 12.5. The max point should be at 45.5. Okay, let's see what we got. Let's just put on one period so we can see it. A period is 5 seconds. Okay, and we're also going to stretch it out a bit, or visually stretch it out like that. There we go. Well, I don't see my lines here. Oh, it should be Y, sorry. There we go. There's my axis. I start at the top, which is good. My top is there. Go down. Boom. They might ask all sorts of questions too, like they would say, how far off the ground are you? This is common, by the way. How far off the ground are you at 4 seconds? Well, you're 34.4 meters at 34 point whatever meter, if they gave meters, at x is equal to 4, right there. They might say, at what time periods in the first cycle are you at that period? And that's because there's 2 degrees that will answer this question. If I look carefully, right, it happened here. But it also happened here. It happened here and here. So it also happened at 1 second. So you have to get used to how to find that. And in that case, you could do it algebraically. And this is important, otherwise I wouldn't bring it up. Sometimes it'll say, what's the height? It'll say, what's the height at 4 seconds? Oh, by the way, I want to do that other thing too. And 4 seconds represents the x-axis. So you'd put into the equation 16.5 cos. And you'd have to figure all this out, 2 pi over 5, and let's say 5 seconds to make my life easier, plus 29. Well, 5 times 2 pi over 5 is this. The cos of 2 pi is 1, plus 29, times 1 is 16.5, plus 29. So its height will be 45.5. We can confirm this with the graph. I chose an easy one, obviously. There it is over there. I'd have to put the equal sign here to see it. There we go. There we go. But you can solve any answer there using that equation. Now, when they give you the time, it's easy. But they might say something tricky like this. And this is important. When is the bike 33 meters off the ground? Solving for X is tough, and this is going to come up. So please maybe memorize or spend some time on this. It's easier if we look at the transformation of this angle later and replace it and just solve for the angle A. So inverse, we have to subtract 29 first. So 29 from both sides, I get 4 is equal to 16.5 cos of the angle. Then I have to divide by 16.4. Cos of the angle is equal to 4 divided by 16.4. Notice that I'm going to get a positive answer. This is when you have to know cast. Cosine is positive in quadrant 1. That's what my calculator will spit out. And over in quadrant 2. Quadrant 2 is the one that's going to be tricky to find. I'm going to go to my calculator. I'm going to keep it in radians. Now, it's not going to spit out any pi's. But I'm going to see cos of my angle is equal to this value. Cos of my angle is equal to this value. That doesn't give me the angle. Right? Now, to solve these, I have to get rid of the word cos. So I have to take an anti-cos or inverse cos of both sides. Inverse cos of a cos cancels this out, and I'm left with angle is equal to the inverse cos of this thing. So I go to here, trig, and I have to hit the second to get the little -1. And I get this answer. This is how many radians. Now notice it doesn't have a pi in it, so this is tricky. I'm going to go back, and I'm going to also show you how it works with the degrees. There we go. And I'm going to switch to degrees so you get a good idea of what's going on. Inverse cos. So this is actually this many degrees. This is a little easier to fathom. Feel free to translate if you want. This is in quadrant 1. It's 75 degrees, 75.8. For now on, I'm just going to say 76 to make this explanation easier. Over here, the 76 is over here, the acute angle between the line and the x-axis. However, I need to find this angle, and this is in quadrant 2, so it's always 180 minus the acute angle. 180 minus 76 is 104. So I'm talking about 76, which is really up here, and 104, which is about here. And that's the two answers. But how do I do it for this? Well, this I have to know that 2 pi is a full circle, and pi is half a circle. Pi represents 3.14. This is clearly less than 3.14. And as I said, the calculator, when it can, will spit out this quadrant or this quadrant as an answer. I need to figure out, so this is my first quadrant. I need to figure out what the angle is in the second quadrant. Well, it's all the way over here, which is 2 pi minus that many radians. So I have to take that number. I have to go back and get the radians. So it's that many radians, and I think I got the right one. And I just have to store it in my memory, and I have to hit pi minus that equals. This is the other degree. You can prove you got it right by converting it to degrees. To convert it to degrees, you have to multiply it by 180. You can convert any radians to degrees by multiplying it by 180 and dividing by pi. You can convert any degrees by multiplying it by pi and dividing it by 180. So if I divide this by pi and multiply by 180, I should get my 75 point whatever I got. Well, actually, this is second degree, so I'll get my 104. So if I divide this by pi and multiply by 180, I should get my degrees. There we go, the 104. And then when I subtract 180, I'll get my original. 75.8. So it worked. So my two possible angles, or two possible angles, are these. But we're not done. Okay? I was just showing you how to come up with trying to clearly explain how to come up with these two. This was the angle here, but remember that I replaced the angle with this formula. So this is equal to the angle, and this is equal to the angle. I'm trying to figure out x all alone. Well, to get x all alone, I have to multiply by 5 to get rid of this, and divide by 2 pi to get rid of this. So essentially, I have to multiply by the reciprocal on both sides. The reciprocal, as I just showed, is 5 divided by 2 pi. That will cancel that value. So essentially, I have to multiply both my answers by 5 and divide by 2 pi to get my seconds. Okay, so the other one's still in there. Yeah, it doesn't matter if it isn't. I will take the 1.32 just like this. And I will multiply by 5 and divide by 2 pi. Sometimes you have to put it in brackets. And it equals, so it happens at 1.05 seconds. And the other one happens at 1.44 seconds. And remember, I was trying to find 33. When we go back to our graph here, we put in y is equal to 33. We discover we got the right answers. Oh, why is that? Oh, cos is positive in... Oh, I did cos the wrong thing. Cos is positive in, my bad, good example. The first angle appears in this quadrant, but in CAST, cos is over here. So I have to take 2 pi, and here's that angle, subtract that angle. So it's not this one. I have to take 2 pi and subtract the 1.31. And that's that angle, so I have to multiply that by 5 and divide it by 2 pi. It equals 3.94. That's where that one is. There we go. My bad. You got to do CAST properly. Can't be too tight. That question is very common.